This is from the May 2017 examinations, paper 1. The first question here is looking at the greatest percentage by mass of nitrogen atoms. So really what that's asking for is the part over the whole. And the part here being the nitrogen, the whole being the whole molecule. So we think about masses. To get mass, we need to look at periodic table. The mass of nitrogen is 14.01. Since we're dealing with a paper 1, that means we don't have a we don't have a calculator that we can use, so really rounding to 14 is a very valid number. If I'm looking at these other molecules here, or the other parts of the molecules, hydrogen, just so I can get ready here, that has a mass of 1. Oxygen has a mass of 16, and sodium has a mass of roughly 23. So if we take a look at these different parts divided by the whole, here I would have 2 nitrogen atoms, each at a mass of 14, so 2 times 14 is 28, divided by the whole, so it would be that 28 plus another 4, because each of the hydrogens are roughly 1 gram per mole. So I would end up with 28 divided by 32, which I can reduce down, since I know what I'm looking for ahead, I'm just going to reduce it to 14/16. Let's look at the ammonia now, NH3. That's just 1 nitrogen, so 14 divided by the whole, 17. And then I take a look at nitrogen, dinitrogen tetroxide. The part is the 28 again, which I calculated up here for N2. Divided by the whole, I've got the 28 plus 4 times 16. So I end up with a mass of 60 grams per mole. And last but not least, I end up with 14, because there's just 1 nitrogen this time, divided by the whole, which would be 1 of the sodiums, 1 of the nitrogens, and 3 of the oxygens, which if you calculate, that's 85 grams per mole. If you take a look at these fractions, clearly the ones that have a really big denominator but a small numerator are not going to be the greatest percentage by mass. They're going to actually be our smallest, so we can cancel out C and D right away. And the reason I got this so close and didn't continue on, I could have done 7/8 and so on and so forth. I didn't need to, though, because I knew from having done the calculations before that I was going to have a 14 in both of these, and then 1's over 17, 1's over 16. Since we know a little bit about fractions, we know that the 14/16 is actually going to be a larger number than 14/17. So A is the correct answer for number 1. Number 2, which statement about mixtures are correct? We've got 3 different statements here, so let's take each one individually. The components may be elements or compounds. That's absolutely true about a mixture. It could be elements, a whole bunch of elements in let's imagine a cup, a whole bunch of elements in a cup together, or a whole bunch of compounds in a cup together. It doesn't matter. So A, or Roman numeral 1, is a correct answer. Then Roman numeral 2 says all components must be in the same phase. That is not true. If you can think of something like soda pop, your Dr. Pepper. Okay, you've got liquid in there. You shouldn't have solid, that would be kind of weird, but you do have gas in there as well. This carbon dioxide particles that are in there are in the gas phase. So that has a gas and a liquid, and it is a mixture, so that is not correct. We can start looking at our answers here. So we know it's not A, and we know it's not D, and we know it's not C. So even without looking at this final one, I can make a pretty good guess that my answer is going to be B. But let's read it just to double check and make sure I wasn't thinking wrong some way in Roman numeral 2. It says the components retain their individual properties. That is absolutely true. The only way that they would not have their individual properties is if they actually reacted, which if they're actually reacting and forming new things, then we don't have a mixture. We have a reaction where we form something new, which might end up being a mixture in its own, but that's dealing with something completely different. When they retain their physical properties, it's just a physical change, not a chemical change. And that is it for today.